Hey there. Hope everyone's hanging in there. Today in O-Level Physics, Lesson 1, Wave Fundamentals and Wave Behavior. A wave transfers energy and information without net transfer of matter. In a transverse wave, oscillations are perpendicular to travel direction. In a longitudinal wave, oscillations are parallel and form compressions and rarefactions. Water surface waves have transverse features, while sound in air is longitudinal. Particles oscillate about eq/lib micrometers positions rather than traveling with the wave from source to receiver. Amplitude is maximum displacement from eq/lib micrometers, wavelength lambda is distance between corresponding points, frequency f is oscillations per second in Hertz, and period t is time for one oscillation. T equals 1, all over f. Wave speed v equals f lambda. A wave of frequency 8 Hz and wavelength 1.5 m travels at 12 m over s, use meters, seconds, and Hertz for direct SI substitution. Wavefront diagrams join points in the same phase. The travel direction is perpendicular to wavefronts, and wavefront spacing represents wavelength. Reflection occurs at a boundary. Angle of incidence equals angle of reflection measured from the normal. Frequency remains fixed by the source. A reflected pulse may invert at a fixed end, but the exact behavior depends on the boundary. Refraction occurs when a wave changes speed on entering a new medium at an angle. Frequency remains unchanged because the source still produces oscillations at the same rate, so wavelength changes with speed. If the wave slows, wavelength decreases and its direction bends toward the normal. If it arrives along the normal, speed and wavelength change but direction does not. Diffraction is spreading when waves pass through a gap or around an obstacle. It is most noticeable when gap width is similar to wavelength. Long radio wavelengths diffract around hills more than short microwaves, while audible sound spreads through doorways. Changing amplitude does not determine diffraction. Ripple tank patterns can show reflection, refraction, and diffraction using evenly spaced wavefronts. Superposition means overlapping displacements add. Two crests can produce constructive interference with larger amplitude, while a crest and equal trough cancel momentarily in destructive interference. After overlap, pulses continue. Graphs may show displacement against distance, where crest spacing gives wavelength, or displacement against time at one point, where cycle spacing gives period. Read the horizontal axis label before deciding which quantity is measured. Identify the graph or diagram axes, measure one or several complete cycles, then use v equals f lambda. For refraction, state what changes, what remains fixed, and relate bending to speed. 6 wave crests pass a point each second, so f equals 6hz. If crest spacing is 0.40 m, v equals 6x0. 40 equals 2.4 m over s and t equals 1, all over 6 equals 0.167 s. Do not say particles travel with the wave, measure angles from the surface, claim frequency changes at a boundary, or say a much wider gap causes the greatest diffraction. Practice. A wave has frequency 25 Hz and wavelength 0.80 m. Find speed. Answer: v equals 25x0. 80 equals 20 m over s. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. Practice. Explain what happens when water waves enter shallower water at an angle. Answer: they slow, frequency stays constant, wavelength decreases, and wavefronts bend toward the normal. Watch the numbers land in the matching symbols. Check that units cancel cleanly. If they do not, the setup is wrong even before the arithmetic. That's all for wave fundamentals and wave behavior for now. When we come back, It's light, refraction, and lenses. Stay curious and see you in the next lesson.